Alright everyone, and welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a timely survey paper published May 5th, 2025, titled Unified Multimodal Understanding and Generation Models, Advances, Challenges, and Opportunities. It tackles the challenge of bringing together two major AI capabilities, multimodal understanding. That's AI making sense of combined text and images, for example, and image generation, where AI creates new visuals. Think of models like GPT-4o, showing glimpses of this potential. Historically, these areas used different methods: autoregressive-based architectures, which build things sequentially, and diffusion-based models, which refine noise into images. This paper surveys efforts to create unified frameworks. And to help folks keep track of all these developments, the authors have also put together a great resource. It's a GitHub repository, acting as an awesome list, essentially a curated collection of related papers, datasets, which are data collections for AI, and benchmarks, standard tests for model performance. This repository is a great companion to their survey for anyone wanting to explore these unified multimodal models further. Okay, so the first figure in the paper, Figure 1, really drives home how quickly this field is moving. It's a timeline showing the release of various unified multimodal models from 2023 up to early 2025. You can see a clear branching out, with more and more models appearing over time. The figure also distinguishes between publicly available models, shown in black text, and those not yet released, in orange. What's also neat is that some model names are underlined. These are what the paper calls any-to-any multimodal models, meaning they can handle inputs and outputs beyond just images and text, like audio, video, and speech. This visual really underscores the rapid growth and intense research activity in creating these all-in-one AI systems. Alright, moving on to Figure 2. This diagram shifts our focus a bit from that timeline we just saw to the actual building blocks, specifically for what the paper calls multimodal understanding models. It lays out two main architectural approaches. First, there's the dual encoder architecture. Here, you have separate encoders, which are AI components that convert inputs like text or images into numerical features called embeddings. These text and image embeddings are then often refined using a technique called contrastive learning, which helps the model learn similarities before a decoder generates the final output. The second, more current approach centers around a large language model. In this setup, visual information, after being processed by its own vision encoder and then a special connector module, which essentially helps translate visual features for the language model, is fed into the large language model, along with text embeddings. The figure also highlights different types of these connectors, like a multi-layer perceptron or a Q-former. So shifting from the understanding models in Figure 2, Figure 3 here illustrates text-to-image generation using what are called diffusion models. The core idea is a two-step process. First, a forward process systematically adds Gaussian noise. Think of it as random static to an image until it's completely noisy. Then, a reverse process learns to meticulously remove that noise, step by step, to generate a new image. This figure shows this happening in a latent space, which is a more compressed, abstract representation of the image, rather than directly in pixel space. And importantly, this denoising process can be steered by various conditions, like text prompts, to control the output. Okay, so building on those generation models, Figure 5 classifies newer unified models, ones aiming to both understand and generate. It groups them by their main architecture. We see diffusion-based unified models. Then, a major category uses a multimodal large language model, or MLLM, that's a large language model for diverse data types, often with an autoregressive or AR method, which processes data sequentially. For these multimodal large language model systems, the figure details image encoding strategies like pixel encoding for raw data, semantic encoding for meaning, learnable query encoding using special queries, and hybrid methods. Finally, it highlights fused models that combine multimodal large language model autoregressive methods with diffusion. That really gives us a good overview of these unified models, from their architecture to the different ways they're being built. It's clear the field is moving towards AI that can both understand and create across different types of information, like text and images, all in one system. This is super exciting because it means we're getting closer to AI that interacts with the world more like we do. That's all for this AI Research Roundup. Thanks for tuning in. I'm Alex.